Actually, I don't have. Last when I took the training, I used uh, 1.4 version, I think so.
Okay, okay, right. Okay, so if you are going Hadoop before 2.0 and Hadoop after 2.0, suppose see here, uh, so we can see the Hadoop versions.
Okay.
Suppose if you're going Hadoop before 2.0, right? So all the versions, generally Hadoop starts from 0.18, the first edition, which is released. So 0.17, 0.8. So right now we reached to 2.7.0, the most latest version, and the most stable version is 2.0, 2.4.0. Okay, so we have Hadoop before 2.0, and we always discuss in the perspective of Hadoop after 2.0. Okay,
Okay.
so we call Hadoop
Okay.
before 2.0. It's generally we have here the Hadoop daemons coming to the main things, the main core components in the Hadoop environment. You can say the Hadoop daemons are the Hadoop processes, right? Hadoop components, right? How we say, like, so we'll have a one name node and some
Yeah.
data nodes are available, correct?
Yeah.
And we
Yeah.
have a job
Second
tracker
one,
is available,
task
and
track.
we have a
Yeah.
task tracker is
Task
available,
tracker.
and the secondary name node is available,
Yeah.
right? So this is
Yeah.
Hadoop before 2.0. So we always works on now Hadoop after 2.0. So it's the same. We have see generally here. So the name node will say like it's a kind of master and slaves, correct? So in the
Yes.
master, what we have a name node, and
Name node. The
data nodes. No, not data nodes. Data nodes are part of the slaves. Name node and job tracker, right, are the master
yes.
nodes, correct? And then
Yes.
if you want to configure a secondary name node, we'll have a SNN as part of the masters, and now the slaves are the data nodes, and the task trackers are known as the slave nodes, correct? So this is generally how we have in the Hadoop before 2.0. Now Hadoop
Okay.
after 2.0, so that is Hadoop from 2.0 onwards. So we always, if you talk about in the perspective of master and slave, so what are the master nodes? You can say we can configure name node as a master node, and as usual secondary name node we have, okay, and then we have HEA node, right, to make the cluster full high availability, right?
Here.
Yes, the complete
Okay.
availability. It's we used to configure a separate node, so that we call it as HEA node. Okay, name node,
Okay.
secondary name node, and high availability, and high available node or say journal node. Some people will call it as quorum node, or the Cloudera they sometimes call it as a shared node. Okay, so then
Okay.
if you configure Hive server is also configured as a master node, and if you are using HBase region server is also known as a master. Okay, now so it's same
Okay.
in the coming to the slaves. Now see here what we have name node, correct? Apart from that, the job is taken by the job tracker. No, now Hadoop in 2.0 onwards, the job tracker is replaced with uh, resource manager. Okay, now we have a resource manager instead of the job tracker, right? Now coming to the slaves, now we have the same thing. All the data nodes are the slaves. So Hive client, HBase client, so they are all known as the slaves. Then instead of the task tracker, okay, so we have a node manager. Okay, it's a node manager, right? So we don't have the task tracker. Now we can run the node manager. So this is the difference between Hadoop before 2.0 and after 2.0. So we are
After
calling,
2.0.
yeah, we are calling this Hadoop 2.0 as yarn. Okay, we are calling it as yarn.
Yeah.
Yeah, yarn, which stands for yet another
There is no
resource
resource
negotiator.
negative.
Okay,
Yes.
Hadoop after 2.0, it's a yarn, it's yet another resource negotiator, right?
So, yeah, I have one question. In slaves after 2.0, there is no task tracker. Instead of task tracker, they mention a name manager, right?
Yes,
Oh,
11 o'clock. Okay, now,
okay,
right, so we have slaves node. See, actually, what happens is, uh, in Hadoop before 2.0, okay, now
okay.
we have only one job tracker. So what generally a job tracker will do, first it has to take the request from the client. After that,
Mhm.
they need to process the client request. It need to take it to the name node. From that, it has to get the reference in the data nodes. Then job tracker has to assign the job to the task tracker. Then the task tracker will execute the job. So as long as task tracker is executing the job, the job tracker, what job tracker has to do now, it has to wait. So job tracker will get the heartbeats from the task tracker, right? It's a
Okay,
process. After that, so that means one job tracker has to do multiple tasks, right? So one job is completed, so
yes,
that remaining jobs are in a queue, or they will be in a pipeline. So it's a little bit execution process is slowed, correct? Now what happens here
yes.
in the Hadoop 2.0 onwards, the job tracker's role is given to the resource manager. So in the resource manager, what we have a resource manager, and we have something like application master. Okay,
Application
so it
master.
is a application master. Now application master will process the job, and resource manager will allocate the resource for the job. That means the job of the job tracker is distributed to two processes. One is a resource manager, so and other one is a application master. Now application master will process the job, the resource manager will allocate the resources for the job to run. Easy enough. Now the instead of the task tracker, so we have a node manager is available. In each data node we'll have one node manager, which it will run the job. Okay,
Okay,
right, so this is the difference between Hadoop before 2.0 and Hadoop after 2.0. Now see, in the Hadoop after 2.0, if you want to use a job tracker, we can use job tracker. Remember this, Raju. We can use the job tracker,
yes,
we can use a task tracker, we can use resource manager, we can use application master. So it's up to you, right? Based upon the properties, based upon the jobs which we are running, we can run the job in either a job tracker, we can run the job on a yard. But in the Hadoop before 2.0, it's completely only the job tracker is available. We never able to configure yarn in Hadoop before 2.0.
okay,
Okay, and so in the Hadoop before 2.0, we used to run the MapReduce jobs. So that time, so when you started learning Hadoop, so the people will talk a lot about the MapReduce. So MapReduce is a mandatory and Java is mandatory, right? You must be hardcore Java programmer, something will be there, right? So in the Hadoop after 2.0, we can able to run non-MapReduce jobs in the cluster. Okay, it should not be a map reduce. We can write both the map reduce as well as non-map reduce jobs in the cluster. Suppose you can heard about the Spark, right? So Spark, right? So we can run the Spark jobs in the cluster. We doesn't support, which it supports, but we don't. Maybe we can write a map reduce, or we cannot write a non-map reduce. Both the jobs can able to run on the cluster. So this is one difference between the before 2.0. So compulsory in the before 2.0, it must be a map reduce job, right? Now in the Hadoop after 2.0, we can write the map reduce as well as we can able to write the non map reduce jobs too. Okay, so this is one main difference. So we can avoid a hard code MapReduce program in the 2.0, right? So now, so when you started Hadoop before 2.0, so what you have to start? So generally, we also discuss these diamonds in the two ways. One is SDFS diamonds, and other one is MapReduce diamonds,
Map reduce.
right? So that means SDFS diamonds
Yeah.
means suppose you started the cluster. So means when you it's when you think if you are saying that the cluster is started, means you have to start SDFS, then you have to start the MapReduce. Okay,
Yeah.
suppose in the cluster only SDFS is running, means you have started SDFS but MapReduce is not started. That is the cluster right now configure name node and the data nodes, secondary name node. So these are all the known as SDFS daemons. Okay, name node,
Okay.
data node, and secondary name node. And what are the MapReduce daemons now? See all the daemons. Say you can say the job tracker or the task tracker, or if you have a node resource manager, or if you have a node manager. So all these are all known as MapReduce daemons. Okay, so now we can start the cluster, means you have to start the SDFS, then you have to start the MapReduce,
Map reduce.
right? So if you started the SDFS, we can able to store the data, but we cannot able to process the data. If you want to
Process the
process
data.
the data, means you have to start
Yeah. Okay. Map
MapReduce,
reduce.
right? That is, we can able to create the files, we can able to copy the files, but if you want to write a job in Hive, if you want to write a job in the Peak or MapReduce, that means you have to start the MapReduce. Okay,
Okay.
and one thing, so generally, so writing a MapReduce program, generally the people will confuse here. Writing a MapReduce program is means, suppose you know the oops, correct, Raju? Oops, right?
Yeah.
What is a
Yeah.
oops? So if you want to write a oops
Uh,
program, so where you write oops, you write the oops concept in, you
yeah.
can use C++ will write,
Okay.
and will write oops in Java. The same thing, MapReduce is a concept, right? You're writing a MapReduce program. That means you're writing this MapReduce in Hive. Are you writing MapReduce in Pig? Are you writing the MapReduce in Java? Are you writing MapReduce in Python? So MapReduce is a concept, right? So which will be executed as a MapReduce process. It's have its own MapReduce processing is there. So that can be done with the MapReduce. Okay,
Okay.
right? Clear?
Yeah. Okay.
Right. Now we can see how to check, right? How to connect to the name node. So you take a Cloudera. Suppose if you want to see your size of the cluster, how many, what are the name nodes, what are the data nodes are available. Okay, suppose take a new tab,
New tab.
right? Suppose in
Right. Suppose in
127,
127.
just let me, and uh, representation of the files, Raju, right? You know how we represent files in the local file system are representing the files in SDFS. Generally, uh, you did.
Yeah. Yeah.
So if you write Hadoop space FSF and LS, what it will do now,
It
right? It will list the files
will
in
list the file.
SDFS, correct?
Yes. Yes.
Okay. So how to represent the files, right? We can represent using two ways. Suppose if I'm going to create a directory, then so what the command, you will write Hadoop space fs-mk dir.
Yeah.
Okay, and suppose I'm going to create a directory with the name Raju. So then the Raju is created in SDFS, means somewhere in the data node. So we have the directory Raju available, correct? So how we
Yeah.
check that? Now if you write Hadoop space fsfn ls, the Raju is created under user Cloudera, right? Raju. Now it is an empty directory. We don't have any files, correct? See, I'll show you one file. I'll copy that. So I'm taking Hadoop fs-. What is the command? Copy from
Mhm.
local. command, right, to copy a file from the local file system to SD. It's same in the mapper, it's same in the Cloudera. Okay, so the same command we use there, right? Copy from local. See here I have a file that is x1.java. Okay, so I want to copy this x1.java to where the directory which I have created is Raju, right? So by default it will be created under user. Okay, Cloudera, and the directory name is Raju, right? So the directory which was created Raju. So right now the file is copied from the local file system. So this is the name of the file, that is x1.java, right? I'm copying it to the directory Raju. Press enter, saying that wrong command, so correct it. Hadoop. Okay, now the file is copied to the Raju. Now see here, what I want to tell you is the representing the files and directories in SDFS. Okay, so we have the different ways. So this we have the what different way how to configure the Hadoop. We'll have the three different ways, right? Any idea about this one, Raju? Standalone installation, pseudo distributed mode, and a fully distributed mode installation. Any idea on
Yeah,
this?
we have we have three configuration: core.xml,
Yes. Yeah.
xml,
No, no, not about the
xml,
configurations. No, no, not about the configurations. It's a different. So see, we can configure Hadoop. Either it can be Cloudera or Hortonworks or the mapper, right? Installation of Hadoop, configuring the Hadoop cluster. So we can configure, right, Hadoop using three ways. Okay. So the first one is which we are saying it as a standalone. Okay. Right. Second one, it is a pseudo distributed mode, is a one kind of Hadoop installation, and the third one is it is a fully distributed multi-node cluster, right? So we have the three different ways we can able to configure the Hadoop. Now see, just try to remember this. So when why we use the standalone mode installation? Suppose if you want to test or the debug the jobs. Okay, only to test and debug the jobs we use a standalone. We don't have SDFS available here, right? We have a local file system, so we'll have some input data is available in the local file system. Now we'll write the jobs in Hive, Pig, MapReduce, Spark, right? So any Hadoop component, it uses the data from the local file system. So there is no SDFS, there is no concept of replication. Okay, it's a standalone mode installation. So the intention for this is to test the jobs, to test and debug the jobs written by you. We configure that. Next one is, see, fully distributed mode. What is a fully distributed mode now? So all the Hadoop daemons, what we have name node. So in one machine, right, in one machine we configure the name node. So in a one machine we configure secondary name node. We configure in one machine, we configure it as HA node. Okay, suppose if you want to configure the job tracker as separate node, we can configure one job tracker, and remaining nodes are the data nodes. Like suppose if you are saying 100 node cluster, right? So if it is a 100 node cluster means, so we have one name node, one secondary name node, one HA node, one job tracker. So remaining 96 are the data nodes we are having. Okay, now that means all the Hadoop daemons, Hadoop processes are distributed to the multiple nodes, right? So this is a fully distributed mode. It's a one machine is a name configured as a name node, dedicated a machine, and one node is configured as a secondary name node, and one separate individual node we configure it as an HA node. One, so generally job tracker resides in the machine where the name node is available, right? But sometimes you have to process more number of jobs, and you cannot able to accommodate both the job tracker and name node in one machine. In that case, we can able to configure job tracker as a separate node. Okay,
Okay.
so in that case, we'll have one extra node that is a job tracker. So this is a fully distributed mode Hadoop cluster. Now here, so we have SDFS is available, okay, and it uses a replication factor is how much? 3, right? Every the file which you are going to write is replicated 3 times. Replication factor is 3, okay, right.
Okay.
Now, pseudo distributed mode. Now what we are doing here is all these Hadoop dimensions what we are having. Now it's a one node cluster, right? One node, or you can say the
Okay.
single node cluster. So in one machine we'll configure the name node, in the same machine we'll configure the secondary name node, same machine will configure the data nodes, right? Everything is available in a one machine. Okay, so that kind of installation is known as pure pseudo distributed mode. It's same, there is only the difference is here we configure everything in a local host. Here each node will have its own IP addresses, because one name node is one machine, so it will have its IP address. One secondary node is configured in a separate machine, so it will have its own IP address, right? One node separately we have configured, so it will have its own IP address. Now to connect it to each individual machine, we have to use this machine's IP address, correct? Now here what we did, in one machine means
Okay.
when one machine will have one IP address, now all the nodes are connected into the same machine, correct? So generally we call it as
Okay.
a local host. Okay, we have configured everything in a one machine. That's we configured how to find a local host mode. Okay, so it is a pseudo
Okay.
distributed mode installation. Now the default replication factor is only 3, right? We have SDFS is available. Replication factor is 1 by default. Every block is replicated only once, and we'll have SDFS is available. Okay, now so right now either you are working in a pseudo distributed mode or you are working a fully distributed mode. Now I'm going to teach you how to represent the files, right? So now what we did here, we have created directory, correct? The directory name is Raju. So right, we'll have one file. See, if you write Hadoop space fs hyphen ls user cloud era, then Raju, we have the some files are available, correct? We have copied the file x1.java. So now how to represent the file with the SDFS. Now if it is a standalone machine, we represent like this. Okay, we can access it like file colon triple slash, because there is no SDFS available in a standalone machine. It's a local file system, right? Your input address is available in a local file system. There is no SDFS is available, right? So if you take a browser and in the new tab, if you write file colon triple slash, so these are the files which are available in a local file system. Okay, now
Okay.
right, so where we have SDFS. Now SDFS means it's available in the data nodes. Now see here, it's a pseudo distributed mode, one cluster, it's a local host. So generally now whenever you create a directory Razu, here we write SDFS colon slash slash. Now you have to write the host name, right? Either it can be a one node
Okay.
cluster or it can be a multi-node cluster. The representation is can be written as SDFS colon host name colon, but if you have to write the port where the name node is running, the port number of the name node, that is 8020. Okay, after that user, the location where the user can able to create his files, that is In the Cloudera, we have user Cloudera and the Raju. So that is now.
Yes.
What is the host name? Take a terminal. If you write host name -v, right? So I'm using the host name. My host name is localhost dot local domain. Okay.
Mhm.
So just check with this one, right? So it will display the host name, right? So here, what is my host name? Localhost. So here I'm writing localhost colon 8020, right? User Cloudera Raju. So this is how we represent the files. Now if it is a fully
So
distributed mode, uh, then what will write? The same thing, though, where the name node is running, what is the IP address of that particular machine? So the same thing, sdfs colon slash slash IP address of the machine 192 something 134.1.0 colon port number of the name node, that is 8020, then user, then Cloudera. So this, in this way will represent the file. Yes,
yes,
Raju.
yes.
Okay. Hmm?
What about the first one, standalone?
The standalone first one, see the local file, right? So we can say file colon triple slash.
Oh,
Okay.
file.
Oh yeah, file
Yeah.
colon
Okay.
triple slash. Now we'll see here. Uh, okay. Open a browser. Right now, remember, generally we have to connect to the name node. See, I'm writing now. We can write that different ways. One is, right, this is where the name node is running, right? Name node is running. What is the host name? 0000, which is a local host, right? And the port number of the name node is 8020. Okay. So just
Oh,
write this one, name node space 0008020, right? Tomorrow I'll tell you some
yes.
commands in suppose you will be in your office. So which command first you need to run to know the name node name, right? Because you don't know whether the 50070 is there or not, right? That's
Yes.
8020 or not, right? So what is the port number, what is the host name? So that we'll see in tomorrow session, right? So today we'll
Mhm.
see the how we access the files, correct? Now if you see here, if you come down, we have an option live nodes and date nodes, right? So the live nodes are the number of nodes which are connected to this cluster. Okay. So now if you have the three node cluster, so if you click this live nodes, now so in my machine I am using Hadoop as a local host, so which I have configured it as a pseudo distributed mode installation, right? Local host, right? So this is the data node where the data is available. Okay. Now see, just open this
Mhm.
name node. Remember 50070 is the web UI port, web UI, which we can able to see the name node. Okay. So write this 50070,
Yes.
right? We'll get the name node web page. So in this one, we have an option here, live nodes. So then click on the local host. Now, so these are the data nodes. And Raju, remember this. Uh, Remember as it is, the users cannot able to navigate to the data nodes directly, right? Suppose you want to see what is the data in some data node, right? It's not possible. Always users have to connect to the data nodes through the name node. Okay, it is a rule,
Yes.
right? If you want to connect to the data nodes, you have to connect it through the name node. So that's what every time why we represent only the name nodes host name with the name node port number. So but because how many data nodes are there, but it's an abstraction, we no need, right? When you're running a job, so how many nodes are there, because it's doesn't, we don't need that, right? It will be abstraction is provided. And the first thing, and the second rule is how many data nodes you're having, but we should always connect it to through the name node. Okay. Suppose see here, If you write data node is available on 50075, if you write 50075, can we able to see the data node? Raju, did you observe here? Can we able to connect to the data node? No, right?
Yeah.
Right. So what is the data node
Yeah.
port number here I have given? 50075. But see here, suppose I'm going to the name node, and now here I'm clicking the button option browse the file system. Now observe this. When I click here browse the file system, I'm opening another tab. Now this 50070 becomes 50075, right? Where we can able to see the data node,
Yeah.
right? So that's what right.
Yes.
So we cannot able to connect to the data nodes directly. We always have to navigate through the name node. Okay. Now here in write user. Okay, in the cloud era. So this is the location where all the users files and the directories are available. User cloud era, and the directory we have created is Raju, right? So you can see here, right? The Raju is a directory now which is created, which is based upon the my system time, right? This is the date and time, right? We'll see in some other time how to change these privileges. Okay, so as of now, the Raju is a created, and we have a one file that is x1.java, correct? So if you click that one, we can able to see. So now uh, we can access this one sdfs colon like this. Otherwise we can access the same with sdfs colon slash slash. Now instead of the local host, the ip address of the my machine is 127.0.0.1 colon 8020. Then user Cloudera Raju. Like this also we can access. That is, suppose if you are using a multi-node cluster, so in the let's this is this part you have to specify the address of the name node. Okay, so in my machine, so this is 127.0.0.1. Now we can see here. I let the different ways. First one is if you write Hadoop space FSF and LS, you can write user Cloudera Raju. In this way also we can give. Okay, otherwise we can write sdfs colon slash slash localhost colon 8020 slash user cloudera Raju. In this way also we can access the files in sdfs. If it is a multi-node cluster, instead of the local host you have to write the ip address. That is may in my case it's a 127.0.0.1. Okay, so in this way also we can able to connect, right? It's a 127.0.1. Okay, otherwise, so what we have seen of all zeros, right? It's a local host, so you can write 0.0.0. Okay, so these are the different ways we can represent the URI to represent the files in SDFS. Okay, and what you remember this, we use the port number 50070 for the name node, right? We can see it's a web UI. Okay, and 50075 is for the data nodes, right? And if you're taking 50030 is for the job tracker, and 50060 is for the task tracker, and if you remember 500790 is for the secondary name node. Okay, so take start, see if you go with 50070, and we can't see 50075 directly, right? That I told. So if you go
Yeah.
3, right, not possible. So we have to navigate through name node.
No.
Right now we can able to see the data node, and to see the job tracker, it's a 50030, right? So this is job tracker. So if you run a job, suppose take a hive, right? Take a some table name, right? You can write a select count of start from user info. Right now this is a map ready job. Now we'll get the job here. Right now see, this is the job which we are running. Right, so whenever we run a job, we can see the job status in the job tracker page, that is job tracker web UI, which is running on the 50030. So this is job which is running in the cluster. Okay, so the job is processed by the executed by the job task tracker, which is running on the port number 50060.
Yeah.
Okay, it's a task tracker. And if you want to see the secondary name node, 50090. Okay, where we can see the information about the secondary name node. Right, remember most of the cases these are same: 50070, 50075, 50030, 50060, 50090.
Okay. So in main mode, we can see log files and FFmpeg, right?
Yes, we can see. Um, right, the location of that one, the location of the name node where we are creating. Right, so just click here. Right, see, these are the name node logs.
Which type is, can you go back?
Back, it's a back.
Yeah. Name no logs, right? You enter?
Yes, this one.
Yeah, okay.
Right, generally we have this cd slash var, we'll have the log files. Right, so this property is specified in a core-site.xml that we'll see the Hadoop configuration files in tomorrow session.
Okay.
Okay, uh, right, clear, Raju? Any other questions here?
Okay. But first, I want the proper installation cost of the cloud era.
Okay, sorry. Okay, so then so he can dump Hadoop into the cloud. Okay, in that case, suppose you want to use Hadoop in Amazon S2 S3 server, or you want to use Hadoop in Cloudera's Hadoop in EC2 cluster. So then we need to configure the Cloudera director. Okay,
Okay.
and the other one is a Cloudera manager, which is enterprise manager, which you have to buy, right, where the client has to buy it. So this is the actual product, right, the commercial product from the Cloudera. So every business must buy, right? That's a Cloudera manager. Right, now we can able to configure the multi-node cluster, and you can see that. Right now you can do this, they'll give you the 60 days trial for this Cloudera manager, so you can have a good hands on this 2 months. Otherwise, if you want to build the complete CDH in your machine, right, so it's a clean installation of Cloudera. Okay, on that case you
Okay.
have to go this one. Right, so it's a clean installation of Cloudera's Hadoop in your uh, machine. Either you can, we have to install Windows or not Windows, CentOS, or you can use Ubuntu, right? It's either Debian Linux or it's an RPM based Linux, right? So you have to go with the steps provided with the documentation, and you can able to configure the Hadoop. It's a clean installation of CTH. So these are the four are available from the Cloudera.